Hello. I'm going to talk about geometry, systems, and substitution. What do I mean by that? I mean that I am going to talk about some linear systems that are based in geometry problems, and I'm going to use substitution in the new way. I'm going to find some new formulas from old formulas using the principle of substitution. So as promised, let's begin by looking at some linear systems that are based in geometry problems. In a certain isosceles triangle, the two congruent angles are each 20 degrees larger than the third angle. What are the measurements of the three angles in the triangle? Now this problem potentially could create a little bit of panic if it showed up on a test, because you might think, what the heck is an isosceles triangle? Well, there's a clue in the problem. It says that an isosceles triangle has two congruent angles. Well, what if you don't know what the word congruent is? There's still another hint in the problem. They're each 20 degrees larger than the third angle. So what this all means is that congruent angles must be angles that have equal measure, and an isosceles triangle is a triangle that has two congruent angles. So I've gone ahead and kind of computer sketched a little isosceles triangle to help us think through the problem. Now the first thing we need to do is we need to define a couple of variables. Because I want to work a lot of examples today, I've gone ahead and pre-typed both my variable definitions and my conclusions. It's important that you copy these down, because when you're working by hand, both of those steps are things that need to be written by hand in the solution that you submit. I've gone ahead and defined x to be the measurement in degrees of each of the congruent angles, and y to be the measurement in degrees of the third angle. So my first objective is to come up with two equations that relate these two unknowns. Let's read the problem again. It says that the two congruent angles are each 20 degrees larger than the third angle. That means if we take the measurement of the third angle and add 20 degrees, we must end up with the measurement of each of the two congruent angles. The measurement of the third angle is what I defined to be y. So when we take y and add 20, the result must be x. Now I've used all the information, all the numbers given in the problem. Where's my other equation? Well, let's look at this little triangle that I've had the computer draw to help us think it through. We have two congruent angles, each of which is measured x, and we have a third angle. Its measurement is y. What do we know about the angles of a triangle? Well, hopefully we can remember that the angles of a triangle sum up to 180 degrees. We have two angles of measurement x, and we have one angle of measurement y, and that sum needs to be 180. There's our two equations relating our two unknowns. Let's solve the system. I think I'm going to go ahead and use substitution. I'm going to substitute y plus 20 for x in the second equation. That will give me 2 times y plus 20 plus y equals 180. Let's solve this for y. Distributing the 2, I have 2y plus 40 plus y equals 180. Combining my y's on the left, I have 3y plus 40 equals 180. Subtracting 40 from both sides of the equation, I have 3y equals 140. And dividing both sides of the equation by 3, I have y equals 140 over 3. 3 does not evenly divide into 140. I know that because the digits in 140 add to 5, and 3 doesn't evenly divide into 5. I am, however, going to make a little bit of an alteration to this value here, because in applied problems, it's probably best not to state your answer using an improper fraction. The reason math teachers get obsessed with improper fractions is because arithmetic is generally easier with improper fractions than with mixed numbers. But to get a quantitative sense of a number, an improper fraction just doesn't work. So what I'm going to do is I'm going to go ahead and write this as a mixed number. How many times does 3 go into 140? Well, 3 goes into 14 4 times, leaving 2 behind. So now how many times does 3 go into 20? 3 goes into 20 6 times, leaving 2 behind. So the fractional part of our mixed number must be 2/3. So the measurement of the third angle must be 46 2/3 degrees. What's the measurement of the two congruent angles? Well, the two congruent angles are each 20 degrees larger than the third angle. So if the third angle is 46 2/3 degrees, the two congruent angles must each measure 66 2/3 degrees. Let's see if this result makes sense in the context of the problem. If the two congruent angles are 66 2/3 degrees, and the third angle is 46 2/3 degrees, it's pretty clear that 66 2/3 is 20 more than 46 2/3. What's the other thing we need to check? We need to make sure that the three angles sum to a measurement of 180 degrees. So we have two angles whose measurements are 66 2/3 degrees, and one angle whose measurement is 46 2/3 degrees. And we want to check that this sum is 180 degrees. You know, 66 2/3, that's just a short way of saying 66 plus 2/3. So we've got 66 plus 2/3 plus 66 plus 2/3 plus 46 plus 2/3. Let's add the integers. 66 and 66 is 132, and if you add to that 46, you get 178. If you have 2/3 and 2/3 and 2/3, that's 3 times 2/3. 3 into 3 is 1, and we're left with 2. 178 and 2 is 180. Our answer checks. Our angle measurements add to 180 degrees. So let's go ahead and state our conclusion. As I mentioned, I've already pre-typed my conclusions. Make sure you write them down because it is part of the hand-solving process. The two congruent angles measurements are each 66 2/3 degrees, and the third angle's measurement is 46 2/3 degrees. Let's do another example. The Antonov twins eat at SubTube a lot. The twins usually share a full-size submarine sandwich. Inga hates it when her brother Yegor gets to cut the sub because he always gives himself 20% more than he gives her. The full-size sub is 11 inches long. How long a piece does each twin receive when Yegor wields the knife? Now I've gone ahead and pre-typed up the really important information in this problem. There were two numerical pieces of information in the problem. One is that Yegor's slice is 20% longer than his sister Inga's slice, and the other is that the total length of the sandwich is 11 inches. We want to figure out how long a slice each of the twins receives, so that's our two variables. Let's define y to be the length measured in inches of Yegor's slice of the sandwich, and x to be the length, again measured in inches, of Inga's slice of the sandwich. You know, I kind of deliberately made y the length of Yegor's slice to kind of get this y association going on there. I need to now find two equations that relate these two variables. Well, one of our equations is down on the bottom right side of the computer screen. What we know is that the sum of the two lengths has to equal 11 inches. The other equation is hidden at the top of the computer screen. Yegor's slice is 20% longer than his sister Inga's slice. So Yegor's slice equals the length of Inga's slice plus 20% of the length of Inga's slice. Y is equal to 1.2x. Here's my system of two equations with two unknowns. This system is just begging me to use the method of substitution. I can take the fact that an expression for y in terms of x is 1.2, and I can substitute that into the second equation. And when we do that, what do we get? We get x plus 1.2x. This sum has to be 11. Combining my x terms on the left, 2.2x has to equal 11. Dividing both sides of the equation by 2.2, x has got to equal 11 divided by 2.2. 11 divided by 2.2 is, going to wait until I get out my calculator. 11 divided by 2.2 is 5. You know, getting a number like that makes me think I should have known how to figure that out in my head, but evidently I didn't. So it's a good thing I had a calculator handy. So x came up to be 5. Since the total of the two lengths needs to be 11 inches, I can figure this one out in my head. It must be that y, the length of Yegor's slice, is 6 inches. Let's make sure all this makes sense in the context of the problem. Two things we need to check. Is the total length 11 inches? 5 inches plus 6 inches, is that 11 inches? Yep. Now what we need to check is Yegor's length 20% longer than his sister's Inga's length. Well, if we take his sister's Inga's length, 5 inches, and we add to that 20% of 5 inches, 20% is the same as 1/5. 1/5 of 5 inches is 1 inch. 5 inches plus 1 inch, what do we got? We've got a slice of sandwich that's 6 inches long. Our answer checks. Let's go ahead and write our conclusions. Yegor's slice of the sandwich is 6 inches long, and Inga's slice of the sandwich is 5 inches long. Here's a new problem. Armando plans to make a jewelry box for his daughter. He wants the ends to be square, and he wants the ratio of the length of the remaining edge to the square side edge length to be 3:2. Armando has 100 centimeters of faux pearl piping he plans to lay along every edge of the box, including the top. What dimensions should Armando use for his daughter's jewelry box? Well, I've gone ahead and had the computer pre-sketch a representation of this cube-like box to help us think through the problem. First thing we need in order to think through the problem is two variables. Let's define W to be the length in centimeters of each of the square edges, and X to be the length in centimeters of the 4 remaining edges. So in my picture, this side is going to have a length that we're calling W, and this side's going to have a length that we're calling X. Now we were told that the ratio of the non-square edge length to the square edge length is 3:2. Remember what ratio means? It means fractions. And when we have two fractions that are equal to each other, that's called a proportion. We have the proportion that the ratio of X to W is the same as the ratio of 3:2. This does not look like a linear equation to me. But you remember how we solve proportions? We employed the principle of cross multiplication. When you have a ratio, you can get an equivalent equation if you multiply the numerators times the denominator on the other side of the equal sign and set those two results equal to one another. That was a lot of words to say 2x equals 3w. So there's one of our equations. I think I'm going to go ahead and solve this equation for x so that I'm primed to do some substitution when it gets time to find the actual solution. So x is going to equal 3/2 w. Now I need another equation. To get my other equation, I need to use the fact that Armando has 100 centimeters of edging to use. What we need to do is we need to count up how many edges of length w we have. We need to count up how many edges of length x we have. We need to add those numbers, and it needs to total to 100. So let's look at our picture. Looks to me like altogether we have 4 sides of length w at each end, so that's going to be 8 sides of length w. And we have 4 sides of length x, the 3 that were already visible, and the hidden side at the bottom back. And this sum needs to equal 100. And remember, we already had the equation x equals 3/2 w. We have a system. Let's solve this system. So 8w plus 4x equals 100, and x equals 3/2 w. Let's substitute 3/2 w for x in the first equation. When we do that, we get 8 times w plus 4 times 3/2 w equals 100. I kind of habitually wrote the 4 as 4 over 1 to help me line up my numerators and denominators when I perform the multiplication. So I have 8w plus, if I do reduction first, the arithmetic's a little bit easier. 2 goes into 4 2 times. 2 times 3 is 6, so plus 6w. This all equals 100. So 14w equals 100. So w is 100 over 14, which is 50 over 7. But remember what I was talking about on an earlier example? I think quantitatively, this number would make a lot more sense if we changed it to a mixed number. 7 goes into 50 7 even times, and there's 1 left over. So as a mixed number, w is 7 1/7. But let's remember the context of the problem. And this is about as real an application as you could get if you're into making things and you have a limited number of resources. W is the length of each edge of the square side, and it's measured in centimeters. So what we're saying is W should be 7 1/7 centimeters. I don't know about you, but the last time I looked at a meter stick, my centimeters were not broken evenly up into sevenths. So I think it would be appropriate to change this answer into decimal form. So let's check out what the decimal is. So let's take our 50 and divide by 7. And we get a pretty icky decimal, 7.142857. Well, let's think about what a centimeter is. A centimeter is a very, very short length. A centimeter is only about this long. So what's 1/10 of a centimeter? It's only about this long. I bet you can't even see a gap between my fingers. That's how small 1/10 of a centimeter is. So I think the smart choice for Armando would be to round this length clear down to 7 centimeters. He definitely can't round up, or else he's going to run out of edging before he gets to the last side. Let's round down to 7 centimeters so that Armando has a little bit of slack room. So I'm going to decide to make W equals 7 centimeters. And when I write my conclusion to this problem, I am going to write a little bit of an acknowledgement that I rounded very liberally, and I'm going to let the teacher know why I rounded so liberally. If we let W equal 7 centimeters, then X, which is 3/2 times W, will be 3/2 times 7 centimeters. That's 21/2 of a centimeter, which is 10.5 centimeters, or 10.5 centimeters. Let's make sure that this answer makes sense in the context of the problem. I still have the equations on the screen, but that's not what I want to check. I want to check the information that was given in the problem. One of the things that I was told is that the ratio of the non-square edge length to the square edge length needs to be 3:2. Our non-square edge length, we think, is going to be 10.5 centimeters, and our square edge length, we think, is going to be 7 centimeters. Let's make sure that's equivalent to 3/2, which in decimal form is 1.5. Sure enough, it is. So that part of the problem checks. The other thing we need to do is we need to make sure that we use 100 centimeters of edging. But remember, we rounded down very liberally. So actually, I think we're going to end up using a little less than 100 centimeters of edging. So we've got 8 sides, each of which have a length of 7 centimeters. And we have 4 sides, each of which have a length of 10.5 centimeters. So that's going to be 56 centimeters plus 40, and 4 times 1/2 is 2, 42 centimeters. So this is adding up to 98 centimeters. That's not what I was supposed to get. I was supposed to get 100 centimeters. But I deliberately chose to round down to give Armando a little bit of slack room. I'm going to make sure I include that in my conclusion. Armando should construct a box that is 7 centimeters by 7 centimeters by 10.5 centimeters. Using these dimensions, Armando will use 98 centimeters of piping, giving himself a little bit of slack room for creating the box. Let's look at this problem. Let's find the equation of the line that passes through the points 2, -5 and -4, 3. Now, a couple thoughts are probably going through your head. Hopefully one of the thoughts that's going through your head is, well, I already know 2 ways to find the equation of a line. Why are you going to show me yet another way of finding the equation of a line? I'm going to show you another method, not so much because I'm suggesting that this is a method that you adopt when you are finding equations of lines. I'm going to show you another method because this skill that I'm going to show you in this example is going to be applicable to something we're doing later on in the course. Another thought that might be occurring to you is, what does this problem have to do with geometry? Well, all of this graphing that we've been doing, that's called analytic geometry. So that's why this example is in the geometry section. How am I going to solve this problem using a system? Well, the equation of this line can be written in slope-intercept form. And when we write the equation of the line in slope-intercept form, the equation is going to look like y equals mx plus b. Now, what do we know about this line? Well, one of the things we know about this line is that the point 2, -5 lies on the line. Now, another way of saying that is that the value of y is -5 when x equals 2. These numbers, when replaced for y and x respectively in our equation, have to satisfy our equation. In other words, it has got to be the case that -5 equals m times 2 plus b. What's the other thing we know? We know that the line passes through the point -4, 3. Y equals 3 when x equals -4. Since these numbers, when substituted for y and x respectively, satisfy the equation, it has to be the fact that 3 equals m times -4 plus b. By golly, we have 2 equations, and we have 2 unknowns. They might not be the unknowns you thought we'd get. You might have thought the unknowns were going to be x and y. It turns out that our unknowns are m and b. We have a system of 2 equations with 2 unknowns, m and b. Let's solve. So our first equation, rewritten in a little more orthodox fashion, said that 2 times m plus b equals -5. And our second equation, again written in a little bit more orthodox fashion, said that -4 times m plus b equals 3. I think I'm going to solve this system using the elimination method. I'm going to multiply both sides of the first equation by -1, which will give me -2m minus b equals +5, and I'm doing that because I could see that then when I add the respective sides of the second equation, b will be eliminated. That's the whole point of the elimination method. So adding up our 2 sides, we have -6m on the left. As promised, b is eliminated, and this all equals 8. Dividing both sides of the equation by -6, we have m equals 8 divided by -6, which is -4/3. So the line we're trying to find, it must have a slope of -4/3. What's b? Well, let's use our first equation to find the value of b. If m is -4/3, it must be the case that 2 times -4/3 plus b equals -5. So b must equal -15/3 plus 8/3, which is -7/3. So it looks like the equation of the line is going to have form y equals -4/3 x minus 7/3. Let's check. How are we going to check this? Well, what is it that we wanted this line to do? We wanted this equation to represent the line that passes through the points 2, -5 and -4, 3. Let's see that both of those points satisfy this equation. If x is 2 and y is -5, then starting with the side of the equation that has some arithmetic involved, we have -4/3 times x, which is 2 over 1, minus 7/3. This is all over 3, -8 minus 7. -8 minus 7 is -15, into which 3 goes -5 times, which is the value of y. Our first point checks. Let's check the second point. If x equals -4 and y equals 3, then -4/3 times -4 over 1 minus 7/3 is going to be positive 16 minus 7 over 3. That's 9 over 3. And guess what? 3 goes into 9 3 times. That's the value of y. This checks as well. Let's go ahead and state our conclusion. The equation of the line is y equals -4/3 x minus 7/3. Now let's use substitution to find a new formula from an old formula. Let's find the formula for the area of a circle in terms of its circumference. Well, a good starting point would be to remember what the formulas are for area and circumference in terms of the radius. We have these formulas, a equals pi r squared and c equals 2 pi r. But these formulas don't really have meaning unless we give definitions for each of these variables. In this definition, a represents the area of the circle, c represents the circumference of the circle, and r represents the radius of the circle. Now what we want to do is we want to take this formula a equals pi r squared and we want to massage it so that on the right side of the equal sign, rather than having the variable r, we have the variable c. Let's give ourselves some room. Let's look at these two formulas. What do they have in common? They both have the variable r in them. So what I am going to do is I'm going to take my circumference formula and I'm going to solve that for r in terms of c, which involves dividing both sides of the equation by 2 pi. Now I have a formula for r in terms of c that I can substitute into my area formula. My area formula says that a equals pi r squared. I'm going to substitute c over 2 pi for r. This gives me pi times c over 2 pi squared. You know what? I bet you this formula simplifies a little bit. Let's see. What does c over 2 pi squared mean? It means that I am going to multiply 2 factors of c over 2 pi. Now again, habitually, I kind of went ahead and wrote the pi as pi over 1 to help me think in terms of what's in the numerator and what's in the denominator. I have 1 factor of pi in the numerator. I have 2 factors of pi in the denominator. Pi over pi is 1, so I can divide the factor of pi in the numerator from one of the factors of pi in the denominator. Essentially, I'm factoring out pi over pi, which is 1. When I do that, what do I leave behind? I leave behind 2 factors of c in the numerator. How do we represent 2 factors of c? C squared. What did I leave behind in the denominator? 2 factors of 2 and a factor of pi. 2 times 2 is 4, so I left behind 4 pi in the denominator. Our formula for the area of a circle in terms of the circumference is the area equals c squared over 4 pi. Let's use this formula. Let's answer this question. What is the area of a circle with a circumference of 10 feet? Now, I don't know about you, but I already forgot what our area formula was. Luckily, the computer didn't forget. The area formula is the circumference squared divided by 4 pi. So if C equals 10 feet, then the value of A must be 10 feet squared over 4 pi. So in the numerator, we've got 100. That's over our denominator of 4 pi. And look at what our units are. They're square feet. That's good. Area units are supposed to be squared linear units. 100 over 4 is 25. So we could simplify this to 25 over pi square feet. But again, this is an applied problem. And the number 25 over pi doesn't make a lot of quantitative sense to me. So I think it would be a good idea to change this to a decimal approximation. So I'm going to get out my calculator. Now, if you watched us during the Math 60 sequence, you might remember that when we did calculations involving the number pi, we just made an approximation using 3.14 for pi. Well, it turns out that this calculator has a pi key on it. The pi key is hidden. It's hidden under the shift key. Maybe that's because pi is a shifty number. I don't know, but let's take 25 and divide by pi. Now, I think I see why pi is a shifty number. It's got a really messy decimal representation. Remember, pi is what we call an irrational number. The decimal representation never terminates, nor does it ever form a forever repeating pattern. Consequently, any calculation involving the number pi is an approximation. So when I hit my equal sign and I get this number 7.9577471, even if I wanted to write down every single one of those digits, I would still have to use a squiggly equal sign because this is an approximation. I'm just going to write down a few of these digits. This number rounds up to 7.96, so the area of our circle is about 7.96 square feet. And it looks like our scrub and bubbles are coming along to make the screen squeaky clean for lesson 4, so I guess that's the end of lesson 3.
1, 2, 3, 4.